Welcome to the Database Mart's channel. In this video, we will explore the inference performance of the NVIDIA A100 80GB GPU under the vLLM framework. We set up the environment using a GitHub project and selected 4 mainstream models from Hugging Face for evaluation. We used a fixed input of 100 tokens and output of 600 tokens, running tests with 50 and 300 concurrent requests respectively. The NVIDIA A100 80GB GPU server is configured as follows. We first tested the Google Gemma 227 billion instruction tuned model, which has a size of 51 GB. Under a scenario with 50 concurrent requests, the model processed 1.94 requests per second, achieving a total throughput of 495.93 tokens per second. When the concurrency was increased to 300, the performance improved significantly, reaching 5.94 requests per second with a total throughput of 1,509.13 tokens per second. This test clearly demonstrates the powerful inference capabilities of the A100 80GB GPU under high concurrency workloads, making it especially well-suited for large-scale deployments and low-latency response scenarios. Next, we tested the DeepSeek-ai distilled version of the Qwen 14 billion model, which is 28 GB. With 50 concurrent requests, the model consistently handled 3.17 requests per second, achieving an overall throughput of 1,450.31 tokens per second. As the concurrency increased to 300, the model's performance scaled further, reaching 8.53 requests per second with a total throughput of 4,187.33 tokens per second. The results show that as the number of concurrent requests grows, the model exhibits excellent scalability in throughput, fully leveraging the computational and memory strengths of the A100 80GB GPU. The third test focused on the DeepSeek-ai distilled version of the Qwen 32 billion model, which has a size of 62 GB. Under 50 concurrent requests, the model processed 1.05 requests per second, achieving a total throughput of 577.17 tokens per second. When the concurrency was increased to 300, the processing speed slightly improved to 1.3 requests per second, with the total throughput rising to 720.75 tokens per second. Compared to the 14 billion version, the 32 billion model shows noticeably lower request handling speed and throughput, primarily due to its larger size and greater demand for computational resources. The final test was conducted on the Qwen QWQ 32 billion model, which also has a size of 62 GB. With 50 concurrent requests, the model achieved a processing speed of 0.93 requests per second and a total throughput of 522.16 tokens per second. When concurrency was increased to 300, the processing speed slightly improved to 1.03 requests per second, and the throughput rose to 702.51 tokens per second. Overall, the QWQ 32 billion model performed steadily under high concurrency conditions, but its throughput gains were limited, highlighting the significant computational demands of large-scale models and the challenges in scaling concurrency efficiently. The NVIDIA A100 80GB GPU performs well with 7 billion to 14 billion language models, offering high throughput and low latency even under heavy load. However, with larger 32 billion models, its performance drops, showing limits in compute power and memory bandwidth. Overall, A100 is a solid choice for most inference tasks, but for larger models and higher performance, the NVIDIA H100 is a better option. Thank you for watching this video. Don't forget to like and subscribe. We will continue to bring you the latest cutting-edge updates.